Hello, Mr. Price here, and this is the video on your Unit 1 and 2 revision questions for the Maths Mastery in Year 8. We're going to go straight into this. So, the first set of questions are testing my knowledge of multiples, primes, and factors. So, from my list above, I am looking for a multiple of 7. Now, I've chosen some numbers here that's going to make this a little bit tricky for you to do. So, possibly you may have instantly seen that what that is. Or I'm going to show you a systematic method as well when I've got a list of numbers. So I know that a multiple is a number in the 7 times table. So I could have 7, could have 14, could have 21. Okay, but I'm looking for a specific one in here that's in the 7 times table. Now this one is difficult to spot, so we're going to go through some of these. Well, you may be tempted to go with 1 if you confused it with a factor, but 1 isn't in the 7 times table, neither is 6. 10 isn't in the 7 times table. 72, you might think, is it? But then you think, hang on, well I know that 7 times 10 is 70, so 72 can't possibly be in that 7 times table, so that's no good. Using the same logic, 69 can't be, because 7 times 10 is 70, so the numbers either side won't be in the 7 times table. And finally I'm left with 91 and 89. Now, you may need to just go through a few of the 7 times tables, and you eventually come to the conclusion that 91 is in the 7 times table. It's 7 times 13. So 91 is a multiple there. Okay, I'm looking for a factor of 3. So in other words, numbers that go into 3. Well, 3 is a very special number. It's a prime number, so only 1 and 3 go into it. So looking across here, here we are. 1 will be a factor because 1 goes into 3 times. Okay, and finally a prime number. Well, I know a prime number has exactly 2 factors. So 1 has 1 factor, that's no good. 6 has at least a few factors because 2 goes into it. With 10, 2 and 5 go into it, so that's no good. 72, it's an even number, so 2 goes into it, so that's no good. 69 is divisible by a few numbers, including 3. 91 we've concluded is in the 7 times table, so that's not a prime number. So that leaves us with 89, and if you're to check it yourself, 89 only has the 2 factors, 1 and 89. So there is my answer for those ones. Okay, 420 is a product of prime factors. Now it's important to note for this question that there are a number of ways that you can do this, so you're not restricted to the choice that I have taken. Now, I know, because the number ends in 0, I know that 10 is going to go into this, so I'm going to choose 10, and a number that multiplies by 10 to give 420, which is 42. Okay, and now 10 can be broken down into 2 and 5. And 2 is prime, so that cannot be broken down further, and 5 is prime, so that cannot be factorised any further. Okay, and now 42. Well, I know it's an even number, so I'm just going to make my life simple and say 2 goes into this, and 2 times what gives us 42? Well, that's 21, and 2 is prime. Okay, and now finally break down to 21. I know that 3 goes into 21 7 times, and those are both prime. Now it might be tempting to finish your answer here, but the answer is specifically asking you to do the product of prime factors, where product means the result from multiplication, and prime factors are prime numbers that go into the number. So here are my prime numbers, or my prime factors, 2, 5, 2, 3 and 7. So the product will be these numbers multiplied together. So I'll just say 420 equals 2 times 2 times 3 times 5 times 7. And that is my final answer. Okay, let's have a look at this one. So I've been given numbers in a Venn diagram, and I'm being asked to find the highest common factor and lowest common multiple of these numbers, and I must show my calculations. So 3 is a common factor for 30 and 3,465, and 5 is a common factor of 30 and 3,465. So here inside my circle are my common prime factors. So the highest common factor I can make with those numbers is 3 multiplied by 5, which gives me 15. 15 is the highest common factor of these two numbers. Now the lowest common multiple can be found by multiplying all of my numbers inside the Venn diagram. Now, I could do 2 times 3 times 3 times 5 times 7 times 11. That's going to take a little while, and I can cheat a little bit here. I know that all the numbers inside this red circle will multiply to give 3,465. So, if these multiply to give 3,465, all I've got left to multiply is that 2. So I can do the sum 3,465 multiplied by 2. And that gives me, if I need to do a little quick sum here, because you're not allowed calculators for these, 2 times 5 is 10, 6 times 2 is 12, carry the 1, 13, 2 times 4 is 8, carry the 1, 9, and 2 times 3 is 6. 6,930 is my lowest common multiple. Okay, let's look at the fractions. So first one is nice and simple. When my denominators are the same, I just add the numerators. 2 plus 3 is 5, so 2 sevenths plus 3 sevenths is 5 sevenths. Part B. Okay. First step here is to get the denominators the same. So I'm looking for a number that's in the 3 and the 4 times table. I'm going to choose 12. You can also use 24 or 36 if you wish, but it's best to use the smallest one possible. I've multiplied 3 by 4 to get 12, so I multiplied 2 by 4, which gives me 8 twelfths. And I multiplied this 4 by 3 to get 12, so I multiply 1 by 3 to get 3 twelfths. 8 twelfths plus 3 twelfths is 11 twelfths. Oops, sorry, I'm subtracting, beg your pardon. Really important you just check that you do the sum correctly there, sorry. So 8 twelfths, take away 3 twelfths is 5 twelfths. And don't do the mistake I did where I accidentally wrote add instead of subtract. Okay, this one, there's a couple of ways you can do this. Now, I am first going to change these into mixed numbers. So 4 goes into 17 4 times. So that's 4 wholes, and 4 fours are 16, so that's a remainder of 1. So 17 over 4 is the same as 4 1/4. I'm going to do the same with 23 over 6. So 6 goes into 23. Let's do the times table. 1 6 is 6, 2 6 is 12, 3 6 is 18, and 4 6s make 24. So that's going to be 3 wholes, and then I'm 5 away to get to 23. So that's 3 and 5 6. I want to add those together. Okay, I've run out of space a little bit here, so I'm going to write my sum underneath. I've got 4 1/4, add 3 and 5 6. Exactly the same method. I'm going to get my denominators to be the same. So what number goes into 4? Sorry, what number is in the 4 and the 6 times table? That is 12. So I multiplied 4 by 3. So multiply the 1 by 3 to get 3 twelfths. I multiply the 6 by 2. So multiply the 5 by 2 to get 10 twelfths. And now all I have to do is add the whole numbers. So 4 plus 3 is 7. And then 3 twelfths plus 10 twelfths is 13 twelfths. Now here I don't want a mixed number and an improper fraction. So once I get to 12 twelfths, that's the same as 1 whole. So that's going to be 8 wholes, and now I've got 1 piece left over out of 12. 8 and 1/12 is my final answer for that one. Okay, and now the final sum here, 2 and 1/5, take away 6 and 6 sevenths. Now, this one is a little bit trickier. You might notice that a 5th is smaller than 6 sevenths. Okay, there's a couple of ways you can do this. I'm going to show you the best way possible, and that is to borrow one of the holes in here and attach it to my fraction. So I'm going to split my hole here into 5 pieces. So I've now only got one hole and 5 pieces plus my other piece here. So that's 1 6/5 minus 6/7. Okay. I'm now going to get my common denominator. Okay, so 35 is the lowest common multiple of 5 and 7. I've multiplied that by 7, so I multiply this by 7. And that's 42 over 35. I've multiplied this by 5, so I multiply the 6 by 5. And 6 5s are 30. So now I've got 1 and 42 over 35 minus 30 over 35. And that gives me 1 whole and 12 35ths left over. And that is everything done. Question D are the most trickiest ones to deal with. If you used another method, that's fine. If you didn't get that as a final answer, then actually you may have also got 47 over 35. Both are correct. Okay, just in different formats. If you didn't get those answers, I recommend just going through that last question and watching it really carefully. Okay, and that is everything done. Thank you.